Hey, welcome to my final presentation, Network Security class with Dr. Calabrese. I'm Bill Hazard. I'm going to talk a little bit about a device called the Cisco Adaptive Security Appliance 5585, or as what it's commonly known as the ASA. The 5585 is an enterprise class security appliance. It's typically designed to sit in a data center as a core device, meaning it would probably see the majority, if not most, of your network's traffic. Given that requirement, it's certainly designed to handle the most extreme operating environments. So what we're going to talk about during this presentation are some pretty basic things to the device, and we'll start with just discussing what the ASA is. We'll get into the technical specifications of the device. We're also going to take a look at why you would need this type of device. What circumstances would warrant this size device or this particular type of device. We'll take a look at where you would deploy the device within your particular network topology. We'll take a look at the device's strengths and weaknesses, as well as any alternatives. Are there any competitive devices out there that would be able to perform at the same capability level? And then we're going to have a discussion with a senior network engineer at Johnson & Wales University, Dennis Foley, who's going to add some real-world experience to the project. Dennis works on the devices daily, and he understands the complexity of the device and what it does and what it should be doing for the network. The textbook definition of the ASA 5585 is that it is a high-performance two-slot chassis with a firewall VPN security services processor, or SSP, and it also includes an IPS security services processor. So it's a firewall with the ability to also serve as an intrusion protection system. So within the two rack unit chassis, you'll have both processors, one your firewall or security services processor / VPN processor, and then secondly an IPS solution or intrusion protection system occupying the top slot of the chassis. The design of the ASA is very simple. On the face of the device you'll see 8 Ethernet ports supporting both 10 gigabit Ethernet fiber connections as well as just regular gigabit Ethernet copper connections. You also have a couple of management interfaces which allow you to connect directly to the device to manage it. You have a USB port. You also have some indicators that will give you local information on the device, such as boot status, any alarm indications, or any type of failover that may have occurred. And then along the top face of the front panel you have a couple of bays that are designed for hard disk in the event you wanted to store local information from the device so that you can retrieve it at a later time. These slots would provide that service. The numbers for the ASA 5585 in terms of its performance indicators are, for its firewall throughput, it's right at about 40 gigabits per second. It is able to handle 350,000 connections per second, and then it's able to handle a maximum of 10 million connections. So it may not necessarily handle those within a second, but it's able to monitor and process a maximum of 10 million connections. So those are pretty good performance indicators for the device, and considering the cost, it would certainly make sense that it's at the top of the line in terms of performance. So let's take a look at the device itself in terms of where it's located in a network and how the traffic would flow through it. In this example, I have a very rudimentary diagram of the Johnson & Wales student internet topology. This is a very basic diagram, and it doesn't show the enormous complexities involved in the actual cabling and or physical locations of the devices, but it should give you a sense of what a packet does with respect to the ASA 5585. As you'll notice, the packet will begin, or it starts from the cloud, hits our border router or BGP router called an ASR 1000, and this router simply combines all the different points of entry or services that we are using to get our traffic in and out of the network. From that point, the packet will then travel to a 6509 layer 3 switch with a firewall services module, or FWSM. And that's because some of that traffic doesn't flow directly to the 5585 after it leaves that 6509. But the student traffic does go from the 6509 to the Cisco ASA 5585, where it will then do a deep packet inspection based on the rules that we establish for student internet traffic. And depending on whether or not that traffic meets those criteria, or that criteria will determine whether or not the packet is allowed to traverse the network. Once the packet leaves the actual device, there is one other device that's part of the security process, and it's called a packet shaper, and that device simply looks at priority in terms of what type of packet, what type of protocol it is, and depending on what that response is, it will give that particular packet a quicker path to its destination, or a slower path to its destination, the actual protocol. So this again is a brief overview, not necessarily designed to provide a blueprint of the network, but just to give you a sense of what our student internet looks like with respect to that device. And here are the actual devices installed in our data center. I apologize for the photographs. It's hard to photograph things inside those frames as well as in the aisles because they're very narrow and you can't get a wide view. But there are two devices, as you saw in the diagram, that simply allows us redundancy. And as you can see, the devices are sitting on top of a couple of larger devices, and those are our Nexus 7000 routers. Those are our core routers. And the ASA 5585 sit on top of that simply for convenience or location in terms of running connections from the core router to that device. So now you have a very brief overview of the device, where it is in our network, and what it does. And I'd like to now turn it over to Dennis Foley. Again, he's a senior network engineer with Johnson & Wales, and I sat down with him and asked him a couple of questions on the device. Bear in mind that there were some concerns with the amount of information or detail Dennis could give during the interview, so we did have to keep some of the specifics of the device under cloak and dagger. So, but I do appreciate Dennis giving me a few minutes to discuss the device. So we'll begin with why we have the actual device, Dennis.
As the internet has come about, we've started, first we had routers which we could route to the internet, and then we found we needed to protect ourselves, so we started putting in firewalls. Firewall is basically a router. A router allows anyone to talk across the interfaces when they configure. An ASA, which we use here, which we use 5505s, 5520s, 5585s, which are pretty much the same device, just more power and bandwidth as we go up. We use them here to allow and disallow people to get to certain resources within the network, within the university, and also out to the network, out to the internet. We restrict a great deal of access of anyone coming in that aren't invited, that you haven't gone out to their website to bring data in. These are done by restricting which IPs can talk out to the internet, which protocols can go out to the internet, not allowing email to pass freely from the internet unless we know who it's coming from. The devices are reasonably easy to configure. Once you learn the basic rules of access lists and how traffic flows, it's just a mirror of each one, changing the IP, the protocol, and a lot of it is understanding specifically what the application needs, depending whether it's a site-based application, a website that we have hosting on site. We can tailor it to reduce that, and it also reduces the number of traffic and utilization within the firewall. If you let everything come in and out, the bandwidth goes uncontrolled, and you have to upgrade very often, which is a very costly issue at this point. We're a Cisco shop, so we stayed with the Cisco ASAs. AS85, we just put two in. so we can do at least a couple gigs of bandwidth out to the internet for the students and the staff, so everyone doesn't have any trouble reaching anything they need to do out of the outside. Now, if you look at the percentage of bandwidth that we use, our staff uses less than 40% most of the time. That's during the day. The students use 60%. Of that 60%, more than half is usually YouTube. It can be looking at movies, sort of video, music. That's the biggest thing of it. And then the gaming is a big piece of that at this time.
I then asked Dennis what his thoughts are with respect to the type of job this particular device would require, or what type of skill set, man hours, etc.
It's the ASAs or firewalls within the university is probably, at this size, could take easily one person a minimum of 40 hours a week. But you add in the new devices that work with the firewall and IDS and things that are looking at applications and keeping people from hacking in and other type of security issues, it's going to be a 1 to 2 man position probably within the next 12 months.
Dennis then discusses the configuration of the device and whether or not it's an easy process or more involved than that.
I find that once you have standard configurations and you know what you have a base of how you're going to do with these, it works very well. But there's so many different options the way you can configure them and use them and manipulate them. Even when I'm dealing with Cisco and having them help me engineer a specific access list and configuration in it, two different engineers at Cisco will give you two different ways to do it. And some it's most optimum and sometimes it isn't because of all the thousands of different ways you can do it.
We then get into a brief discussion on any alternative devices you would use in place of the 5585.
We've stayed with Cisco. Well, the firewall solution is Cisco. We're looking at the QRadar, which we have now for doing the IPS and IDS. We're looking at SourceFire. There are a lot of other firewall, or they sort of supplement the firewall. And we have what we call an AGOSEC device that analyzes our firewall rules. And it tells us which ones have holes in them, which ones aren't really strong, and how to strengthen those. And gives us an idea of how many people are hitting a firewall rule.
We then conclude the interview with Dennis sharing some experience with respect to where security or network security has come from, and maybe where he sees it going in the future.
I worked at Fidelity, and when I started at Fidelity, they probably had an engineering department, 20 guys. We put a couple of guys in the firewall. And that's what's happening here. We did firewall changes, we didn't do much. They had an incident and they started looking into it deeper and they started bringing in other devices to look at things and realized that people had penetrated the network much more than they had assumed. When I left there after 10 years, the security, firewall, QRadar, and multiple other devices, Checkpoint, the network, that security department had become larger than the network department.
Wow. So there you have it. I hope the presentation was informative. Again, I apologize for the ambient noise during the interview, but hopefully you picked up a couple of different tidbits of knowledge on the ASA. Thank you.